Welcome everyone to Pomodoro Joe for Tuesday, January 10th, 2023. And today we'll be working on LeetCode problem 100. Same tree. It's an easy problem. And the problem statement says, given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. All right. So we're checking to see if two trees are the same. They don't have to have the exact same node, meaning the same shared memory, but they do have to hold the same values in the nodes at the same places. And they have some examples and some constraints, but it looks like they're all reasonable, so we don't need to worry about those. Okay, so anytime I'm given a binary tree problem, particularly one where I have to do a tree traversal, the first thing I think of is a recursive algorithm. If we do this recursively, it should be fairly straightforward. All right, so let's set 25 minutes on our Pomodoro timer and jump right in. Okay, so in the recursive algorithm approach, the first thing we want to do is look for our base cases. So in which cases are we not going to call this function recursively, but break out of the function and return a value? So the first case here, we can see that we've got optional nodes P and Q. So if both of these are none, then we can just return true at that point. So if P is none and Q is none, we can just return true because these are the same trees, empty trees. All right, now the next thing I want to do is if P is not none, but Q is none, or if Q is not none and P is none, then I want to return false. So if either one of these is none and the other isn't, I'll return false. Now I could write all that out, but we've already checked that both of these are not none, or if we got past this check that they are both none, then if either one of these is none, that means the other one cannot be none. So in this case, I can just say if P is none or Q is none, I already got past this check, meaning that if P is none, that Q must not be none, or if Q is none, then P must not be none. And if that's the case, then we return false because these are not the same. Only one of them is none. So now we have two base cases. Are there any other base cases? I think this is kind of the extent of our base cases. Now we get down to our recursive cases. So one thing we need to check is if P's value is equal to Q's value. Now, if they are equal, then we'll continue and we'll do some more checks. But if they're not equal, then we know we can return false. So I'm going to check that they're not equal, and I'll return false if these two don't match. And then finally, this is where we get to our recursive case. I really want to check if the left is the same and the right is the same. And how do we check to see if the left branch of this tree of P matches the left branch of Q? Well, we just call our same function. This is sort of the magic of recursion. We assume that this function works, and because we're writing this function with these base cases, we can go ahead and call the function internally to say, if we know that these root nodes have the same values, then let's check to see if the left and the right also have the same values. And so I want to check P.left against Q.left, and I want to check that the right values are the same as well, or the right branches are the same. I'll check on P.right and Q.right, and we'll call this right same. All right, now if we make it this far, we know that the nodes themselves have the same values. We also know whether or not the left and the right branches are the same. So we can return left same and right same. So if both the left branches match and both the right branches match, then we have a matching tree. Let's give this a shot. And it works. So that's pretty much it for our algorithm. Couple things to note. Recursion can be tricky, especially when you're first starting out. It can be hard to think about, but one magical way to work on, to One way that I find that helps me with recursion is to sort of think magically that just magically this function works. And if this function works, then this is how we would write our algorithm. So we assume that isSameTree works. We write our base cases. Then at some point we say, well, we need to check to see if the left branch of P matches the left branch of Q. Well, we have a function that's supposed to do that, isSameTree, so let's just call it. And so magically it all works out because we have these base cases. All right, so we'll go ahead and submit this, and then I'll do a little bit of optimization to see if we can get a better score depending on whether or not this passes and what score we get. All right, and we pass. And it's not too bad. We beat 73% of other submissions for runtime and 72% in terms of memory. So that's not too bad. All right, well, let's jump back and do a couple small things to optimize. So there's not much we can do here to optimize, but one thing we can do is we've got these temporary variables that we hold on to, these recursive values. We can just replace those. We don't actually need those. So we can just directly call our function here and get rid of these temporary variables. And that might give us a tiny little bit of speed up. It does make this a little bit harder to read, so I don't necessarily recommend this for production, but in this case, we're just seeing if we can get a little bit of a bump in our performance. And in fact, it does not help our runtime, makes our runtime significantly worse. It does help our memory quite a bit. So we beat 98% in terms of our memory, but we only beat 58% in terms of our runtime. So the trade-off, depending on if you're memory constrained or runtime constrained, this might be a trade-off you'd want to do, or this might be a trade-off that it's not worth the complexity in terms of reading the code and the runtime hit that you're going to take when you do this. I'm not really sure why this takes a runtime hit. It doesn't seem like it should, but clearly it does based on our metrics. All right, I think I'm going to leave it there. This was a quick one, short and sweet. So tree traversal, use recursion, and yeah, remember your base cases. Go out and write better code.